Hello, this is Sumner with a physics test. This is the problem we're going to be solving. We quickly just want to get all of our variables that we know over here, and that's going to make it easier to solve the problem. H equals 1 meter, height equals 1 meter, theta equals 30 degrees, and mu, or coefficient of friction, equals 0.2. Okay, so then we want to determine what we're actually looking for. The first thing we're looking for is speed, or what is the block's speed at point B. So I'm going to call that, for now, I'm going to call that velocity, and then it's complicated since we have multiple points. I'm going to call that velocity 2 equals question mark. B, what is B? B is just looking for the work of friction. So we'll just do work friction equals question mark. C is looking for the distance it travels at the end. I don't know, and D we'll get back to later. So first what we want to do is we want to determine equations that we can use. So we have M, height, and we automatically have G, which is just 9.81. So we automatically have M, G, and H, so we have potential energy equals mgh, and that, because theoretically this top part is frictionless and we're only looking for the speed at this part before it touches any friction, it should be the exact same. The kinetic energy should be the exact same as potential energy. So that means we can pull in this equation right here, and this should be true. Now we can solve, basically, just because what we want is we want to get V isolated. So V equals, we'll just divide this by M2, so this will just be 2M. This will be 2GH equals V squared, and so we can go down and just be the square root of 2GH equals V2. Okay, now we know V2. That's the first question. We can solve and plug that in if we want, and we'll just get the square root of 2 times 1 times 9.81, which is just the square root of 2 times 9.81, which will give you 19.62. And with that, we can just roughly guesstimate that is approximately 4.43. Okay, so this was all part of A. This was all part of A. We can square that off, and we can go over here and look at B quickly. B is pretty simple because the work done on the object is equal to its speed. So its speed at the initial point, because the final speed, so it would be, we would get basically work equals 1/2 mv squared, but this is going to be v3 minus 1/2 mv2 squared, which will just give us, which we can just eliminate this because we know v3, it's at rest, so v3 equals 0. So then we just have negative 1/2 of mv22 equals work, or if we want to translate that to make it a little bit easier, we can just say work equals mgh, because we know that's equivalent from over here, but it equals negative mgh, because we've determined that's equivalent. And then, so we have work now. How much work does the floor do? C. We have C. Now, C is trying to find out how far it would actually go. So what we want to use is we want to use work equals force times distance. And now this is going to be the force of friction. This is all work of friction, work done by friction. If we go back up, this is all work done by friction. So we want to first isolate, first we'll expand. So we'll first expand, and work we've just determined was mgh, and then we can expand force of friction, which we can just say is mule of mg, and then distance. So we want to isolate distance, so we can divide this all by mule mg, and these two mg's, so this cancels out, and then mg cancels out, and we'll get height divided by coefficient of friction equals distance. Now, if we plug in these numbers, we'll go and we'll get height, which is 1, divided by coefficient of friction, which is 0.2, equals distance. So distance equals 5. And then we can go back up here and plug this in if we want to, which will just be m times g, because h is 1 and doesn't matter, and we'll get roughly 49, I believe. And then so D is here. So what it's asking is if the coefficient of friction changed, would the work change, and would the distance change? Now the work is equal to force times distance. So, well, the distance, well, let's first do distance. So distance would effectively, this equals 5. So then if we put this same equation, height over mule, or coefficient of friction, equals distance, we would get 1 divided by 0.4, which would give us 2.5, which is half of that. So the distance would halve, but would the work change? The work would not change, because, well, the distance halves, so the work of friction would not change. The distance is 1/2 of distance, but the force is greater, because the force applied is greater, because this is the force, because if we expand this, then we'll just get work force equals, and then mule mg, and then so distance would be 1/2, but that doesn't matter. So then we could also expand distance, which would be h over mule. And so if you see this, the mules, this would all multiply, and the mules would, and so you would divide this, you would multiply this, and the mules would cancel each other out, leaving you with just mgh equals work of friction. So the distance slash part C would have distance would have, but the work would remain the same. That's my answer to part D. I believe I've answered every question. Thank you for your time.